and girls, we're back and we're going to have another math adventure today. Today we're going to take a look at long division. I know some of you are already moaning in pain, but trust me, we're going to get through this, we're going to develop this skill, and you'll feel quite confident when we're done. Let's try some. Hello boys and girls, let's take a look at long division, but before we start with long division, let's take a look at division in general. Now here we have a fraction. That's what you're all saying. Some of you are saying it's an improper fraction because the numerator is larger than the denominator. And I'd have to agree with that. This is an improper fraction, but it's more than a fraction. In fact, every fraction is more than a fraction. It's really a division problem. 4 halves is really the same thing as 4 divided by 2. And we can express 4 divided by 2 also as a long division problem, 4 divided by 2. And we'll take it one step further, and we're going to save this for later. I'm just planting some seeds here. 4 halves, or 4 divided by 2, is really also a ratio. I'm comparing 4 to 2, and I can write this ratio also another way, 4 to 2. Now, I'm going to save ratios for later, because what ratios really do is they create a comparison. I'm saying 4 of something to 2 of something, or every time I have 4 of something, I'm going to have 2 of the same thing or of something else. There's a rule or pattern here. There's a relationship that's being compared. And if I were to simplify this ratio, which we'll talk about later this year, I can reduce it into what's called a unit rate, which is very useful. But I just want to plant some seeds here. We're going to talk about ratios again. Ratios are really just another type of fraction or division problem. Okay, save that for later. But back to long division. Let's take it and let's talk about division in general too. Get out your long division guided notes. When you read the definition, it might sound a little wordy. It says dividing is the act of separating the whole, or dividend, into equal parts, which is the divisor. Simply stated, how many times, which is the quotient, can the parts or the divisor fit into the whole, which is the dividend. Okay, it's a mouthful, but what I'm really saying is if we take, for example, 24 divided by 6, now you good mathematicians out there all know it's 4. But what's going on here? I'm saying how many times does 6, okay, which is my divisor, fit into my dividend? Well, how many times can it fit in? Well, how many times can I take it out? So if I were to take 24 and subtract 6 from it, I'd get 18. Okay, this is pretty easy. And I could take another 6 out, okay, and I'd be left with 12. And I could take 6 out again, and I'd be left with 6. And finally, I could take 6 out one more time, and I'd have nothing left over, no remainder. So in other words, I can take 6 will divide or subtract out of 24
It's 4 o'clock.
times. Wow, that's pretty interesting. 4 times. So what we're really saying is division is what? Division is repeated subtraction. Wow. Moving right along, let's take a look at a sample problem, and we're going to practice our 5 steps of division. But first, we have a standard division problem, 425 divided by 25. The first step is we need to take our first number, our dividend, and put that in the house. I refer to this division bar as the house. So the dividend goes in the house. The first number goes in the house. The second number goes out front by the front door. And we're going to do all of our work down here in the basement, and we'll put our answer up here on the roof. Okay, maybe this will be helpful to you guys. Now, here's the 5 steps. We divide, multiply, subtract, check, and bring down the next digit. And I want you to follow along and do this problem with your guided notes. Now, we first take our divisor here, and which is 25. Our divisor
Let's label it. Okay, here's our divisor. Here's our dividend. And the answer is going to go up top here on top of the roof, and that's called the quotient. We'll get to that. I might as well label it. It's going to be up there. Okay, the quotient goes up here on top. But here's our 5 steps. Divide. We take the divisor. 25 will go into 4. How many times? 0. Okay? And then we multiply. That's the next step. We take 0, multiply by our divisor, and that will give us the product of 0. And then we subtract. Okay, when we subtract, we'll get 4 as our remainder. We check, is our remainder greater than our divisor? Nope, so we can keep on moving. And then we bring down the next digit, which is 2. And then we start all over again. We start by dividing. 25 goes into 42 how many times? Once. So I put 1 right there. Then I multiply. 1 times 25 is 25 is my product. Now I'm already feeling like why this is called long division. It's taking a long time, but it's worth it. It's a lot shorter than doing repeated subtraction. Okay, we subtract and we get a remainder of 17. Then we check. Is our remainder less than our divisor, 25? Yes, it is. So we can keep on going. And by the way, if your remainder is ever larger than your divisor, that means that this number up here could have been larger. That 25 could have factored into your number more times. So let's continue. After we check, we bring down the next number, next digit, which is 5. Okay, and then we start all over again. 25 will go into 175. How many times? Well, I know 25 goes into 100 4 times. 25 goes into 75 3 times. So there we have it, 7 times. 7 times 25 is 175. Or 25 quarters is $1.75. And then we subtract and we get 0. We check. Is our remainder less than our divisor? It sure is. And then we go to bring down our next number. There is no next digit. So we are done, and we put our remainder up here of 0, or no remainder. Now, do you have to put a 0 here as a placeholder? No. If you just would have written out 17, that would have been fine. But this is really good to put a 0 here just to keep our placeholder there and to keep everything nice and neat. So there you have it. There's the 5 steps of division. Divide, multiply, subtract, check, and bring down the next digit. You repeat these steps until you run out of digits to bring down, and then you put your remainder up top. And you might want to remember divide, multiply, subtract, check, and bring down is, does McDonald's sell cheeseburgers? Okay, there you have it. I hope that was helpful, and we'll be working on some more problems in a moment. Okay, boys and girls, let's do one more division problem. We're going to start with this fraction of 10 thirds. We'll write it as a long division problem, 10 divided by 3. We'll follow our 5 steps of division, which is divide, multiply, subtract, check, and bring down. But this time, we are not going to have a remainder of an answer. We're going to keep on going. We're going to get a decimal answer. And we'll handle it the same way. 3 goes into 10. Well, 3 goes into 1 0 times. 0 times 3 is 0. We subtract. We get a remainder of 1. 1 is less than our divisor of 3, so we can keep on going. We bring down our next digit, which is 0. 3 goes into 10 3 times. We multiply. 3 times 3 is 9. We subtract. We get 1. Our remainder is less than our divisor of 3. We can keep on going. We go to bring down our next number. We don't have a number there, but what we can do is we can put a 0 there. After all, we know that 10 is the same thing as 10.0, or 10 is equal to 10 0 tenths. We're really not changing the value of 10 at all, but this helps us in this division process. We bring down a 0. We put our decimal point there and there in the correct columns. 3 goes into 10 3 times. 3 times 3 is 9. We subtract, we get 1. And I think you can see what's going to happen here. We can put another 0 here, bring it down. 3 goes into 10 3 times. 3 times 3 is 9. What happens here is we have a repeating pattern. It just keeps on going on and on. And when we have what we call this is a repeating decimal. And the way we would write this is 3.3 with a line over it, or 3 3/10 repeating decimal. And this line over the 3 in the tenths column tells us that this 3 will continue, just keep on going. So this is actually 3.33333 on, and it will not stop. It just keeps on repeating. Okay, so this pattern is a rule. It's just going to keep on going. And there you have it. I'll see you again soon. Bye-bye.
I hope that was helpful once again. Now, just remember, a pattern is a rule, and a rule is a pattern. I'll see you soon. Bye-bye.